Hello everyone, welcome to the another video of UGB 2024 solution. So I have discussed every problem except the last one. So yesterday 12th May was the exam and today is 13th May. So I posted most of the solutions by night, and so now posting the last one. So the thing is that the last one is a combinatorial question and it's a very interesting question. So it says that you have a round robin tournament and the winning team gets 1 point and the losing team gets 0 points, and everyone plays with the other team exactly once, and at the end of the tournament total points received by the individual teams are arranged in decreasing order as follows. So whoever team got the highest point, so that is x1, then x2 and so on till xn. Okay, so basically you can also think like this, that is you are arranging the players in decreasing order of the number of wins of them. So now try to think that we have to prove that xk is n minus greater than equals to n minus k by 2 to less than equals to n minus k plus 1 by 2. So first let's go to one side, let's go to the left hand side inequality. Okay, so for k greater than equals to 1 and less than n. So now try to observe the pattern. So how do you come up with the idea? So try to observe the pattern what you are getting. So you have to prove that x1 is greater than equals to capital N minus 1 by 2, and then you have to prove that x2 is greater than equals to capital N minus 2 by 2. Okay, and so on and so forth. So what's the idea? Like, why should x1 be like so what is it saying is that whoever has won the highest number of games, the maximum number of games, so that maximum number in any scenario, in any tournament, however it's played, however the match went, all those matches went, so the minimum possibility of the maximum number of wins is n minus 1. It can't go below this. Okay, so that's what it is saying. So like, what does this inequality denote? That is for the maximum, let's just concentrate on x1. So the maximum number of wins, what could be the minimum value of it, what could be the maximum value of it? So as you can very well see that the maximum value is like the team has won all the matches. So if you just put k equals 1, you can very well see that that is coming out to be n minus 1, and so each team is playing n minus 1 game, so they have won all the games. So that's the maximum. Now what could be the minimum? It's saying that the minimum is n minus 1 by 2. Now the question is why? So now try to think that if x1 is attaining the minimum possibility, okay, so like what could it be? Or if like x1 is x1 is taking its minimum value. Okay, so what could be the worst case scenario? Like, what could be the bare minimum value? So the thing is that in that scenario you can think like this, that is all the teams can win the same number of matches, right? You can just simply let's say that you can just simply take an example, okay, so, and construct such a game where every team has won the same number of matches. Okay, so not that very hard. So the thing is that, so then we get to see that the minimum can be like what is capital Xn, so that is throughout equal, like all the teams have won the same number of matches. So in that case what will happen is that we would be getting the total number of matches is capital N times capital N minus 1 by 2, basically capital N choose 2. Okay, and so now we know that like that will be equal to x1 times capital N, and so that's why like now cancel out capital N and you get that the minimum possible value of x1 is n minus 1 by 2. And the same goes for, now you will say that why for x2? Now for x2, just forget about the team who has won x1 number of games, just delete that team. Okay, so now just concentrate for the teams from x2 to xn. Okay, so in that case again how many games are being played. That is, you have now n minus 1. So again, like I'm just removing this inequality. Okay, so here what you're getting is basically this. Again, for the minimum possible value of x2 could be like all of them are equal. Okay, and so that's the bare minimum, and all of them are, when all of them are equal. So what you get is basically like how many matches are being played, n minus 1, and so how many teams, n minus 1 times n minus 2 by 2, total number of matches are being played, and then it's basically like so I mean that should be like the sum of all these xi's, right? So x2 times n capital N minus 1. Okay, so now why am I going for this equality? Try to understand that I am summing up all the winnings, so that means it's basically the total number of matches. So here also the same thing. Okay, if I just if I delete x1, if I just concentrate on from x2 to that xn, so again you can think like this, that is just forget about that team who has won x1 number of games. I'm just deleting that. Okay, so then try to think that what can you say about like from x2 to xn. So again these again you would say that the value of x2 will decrease and so on. So okay, fine, I agree with you. So think of it as a graph, a connected graph. Okay, so you just remove that graph. Okay, sorry, you just remove that vertex away, that player away. Okay, and now I'm just concentrating on the rest of the graph. Rest of the players are playing. Now I'm just concentrating on so as I said, like these x1, x2, x3 till xn, so they are nothing but like you can think of them as teams as well. Okay, the first team, the second team, the third team, and so on. So now I'm just concentrating on the games that are being played by those team 2 till team n. Okay, and then I can very well say that like whatever be the number of winnings of the team 2, okay, who has won the second highest number of games, so what could be that? So if all of them are equal, so that it's getting the minimum possibility, and so there I am getting that x2 is nothing but like n minus 1 times n minus 2 by 2, that is the total number of games, and if all of them are equal, so it's x2 times n minus 1, and so this n minus 1 gets cancelled out, and we get this to be x2 is greater than equal, so this is the minimum value of x2. Okay, now so that means we can easily say that even if I just concentrate on the round robin tournament of the teams T2, T3 till Tn, so again I get that there itself x2 is greater than equals to n minus 1 n minus 2 by 2. Okay, and so the thing is that if I now let that team 1 come back again, which I deleted, so that team 1 will play with that team who has won x2 number of games, and that then what if the team 2 defeats team 1, then the value will increase, the value won't decrease, right? x2, that value won't decrease. If I bring another player, that value won't decrease. So either like when it plays with the team 1, the team 2 when it plays with the team 1, if they lose, then it's fine, the number of games they have won, it's fine, it's at least n minus 2 by 2, and if they further win with the first player, then it gets more. Okay, their winning gets more, so at least n minus 2 by 2. Okay, and so on and so forth. So the like if I just try to go for the general for any particular arbitrary k xk, so then I'll just concentrate on the team tk till T capital N. Okay, they are playing the round robin tournament, and then what I get is that like I have to like so I have to prove this. Now what will happen, like this thing, that is how many teams do I have? N minus k plus 1 times n minus k divided by 2, and that is basically equals to xk, and xk till TK till TN, I'm considering that they will get the least when all of the teams have won the same number of games. So then we get that this is nothing but n minus k plus 1. Okay, so now again I see that this cancels out, and so the minimum possible value, if team TK to TN they only play the round robin, the minimum possible value of xk is greater than equals to n minus k by 2. Now if I bring the other players back, so again this value is not going to diminish. I mean, this value is not going to get lower. It's going to get higher. Okay, so that's why the minimum possible value of xk is greater than equals to n minus k by 2. So we are done with the left hand side inequality. Okay, so k running from 1 to n. So k going from 1 to less than capital N. Now what is that, like so I for the right hand side inequality I'm going to use this same idea. Okay, so basically this inequality. Now think that according to the, so let's, yeah, now according to the number of wins, these teams, according to the number of wins, this sequence has been arranged in a decreasing order, right? Now try to think that what I am trying to figure out is that for now I am going for the right hand side inequality. The right hand side inequality, I am trying to concentrate that for x1, okay, what could be the maximum number of wins. So you can very well see that the maximum, if x1 tries to achieve the maximum number of wins, so that means it has to ensure that it gets the minimum number of losses. Okay, the minimum number of losses. So the what is the minimum number of losses? That is 0. Okay, so no loss. So that means all the matches they win. Okay, so they didn't lose any match. So that means what? Now what we can say is that, like, let's take that for team 1 it's x1, for team 2 it's x2, and so on. Okay, so now team 1, I want to see that, I want to calculate like their maximum number of winnings, so they can win all the games. Okay, that is a possibility. So that means I now will concentrate on the number of losses. So that means for those teams the number of losses should minimize. So what will happen? That means the inequality will just get reversed. That is, if I just take, let's say, x1 dash is the number of losses for x1. Okay, now similarly x2 dash is the number of losses for the team 2, and so on and so forth till xn dash, or you can take complement, is the number of losses for x capital N. Now try to see that if x1 is the maximum number of wins, so that means what? That is, x1 dash will be the minimum number of losses. So this will be the inequality then. Okay, for the losses, just similarly how they did it, like they just took the winnings and the maximum win, the second max, the third max, and decrease. So I'll just similarly do it for the number of losses. It's just win and loss. It's just binary, 1 and 0. You can just doesn't matter. So so what I'll do is, like, now with like the number of losses, I'll concentrate on the number of losses. So now I will be checking who has the maximum number of losses, and then who has the second max, and so on and so forth. And so this is what is coming out. That is, the team T1 should have the minimum number of losses. The team T2 should have the second minimum number of losses, and so on. Tn should have the maximum number of losses. Okay. Yes, because they are winning the minimum number of games. And so now just try to concentrate here. That is, for this one, for this sequence, so it's just the same as the original sequence, the original one, just it's that it's the losses and it was the maximum wins. So now what I know is that like xn dash, okay, so this team Tn will will lose the maximum number of games. So again, as we proved that, now for try to understand that xn dash will be getting the maximum number of losses. So for that losses, what could be the range? Okay, so now we know that that is nothing but basically what we have is that is I mean, try to understand that it's nothing but it's just the same as what was happening with x1. Okay, so we know that for the team 1, its number of winnings is x1, the max possibility of x1 and the mean possibility of x1 and the max possibility of x1. So same as here for xn dash. Okay, so for xn dash, now we know the minimum number of losses and the maximum number of losses is just win and loss. Nothing is changing. The same concept, whatever we did here with the wins, it's just the word is changing to loss and everything remains the same. So we can then say that since the minimum possible value of x1 was capital N minus 1 by 2, so xn dash will also be greater than equals to capital N minus 1 by 2. Okay, even if you are confused here, just replace this sequence as like, let's say that take xn dash as y1, x capital N minus 1 dash as y2, so y1 greater than y2 greater than so on till greater than equals to yn. Okay, and so this and this, the original sequence are exact same. It's just it was the win and this is the loss, so it doesn't make any difference. So I know that xn dash it has the its losses. So the minimum possible value, because why am I going for the minimum possible value of losses? Because for each team now I want to figure out the maximum possible wins. So to get the maximum possible wins, I have to minimize the losses. So that's why now xn dash, I can see that it's greater than equals to n minus 1 by 2. Similarly, x n minus 1 dash will be greater than equals to, it's the same as what happened with our x2. Okay, the second term. So that is n minus 1 minus 1. So that means you can very well see it's n minus 2 by 2. So I'm writing it as n minus 1 minus 1 by 2. So now you can see the pattern and you can easily prove that xk dash is greater than equals to that is what we are getting, the pattern k minus 1 by 2. Okay, so this is nothing, we already proved it. Like you can easily say that using the previous one, because we proved that for such a sequence this is going to happen. We proved the left hand side inequality, so I'm just using the left hand side inequality and nothing else. So and just a matter of the index, so the index you have to like clearly mention. So the thing is that we are getting that xk dash, which is the team kth team, its losses, the minimum possibility of its losses is k minus 1 by 2. So then the maximum possibility for like xk, the team k, its maximum possibility for its winning is, that is total number of games is n minus 1 and minus, if I do x minus 1 by 2, so this will be less, because see, total number of games I am subtracting the minimum number of losses it can do, so that means I am maximizing its win, and so that is basically coming out to be this is what, this is n and this minus is going, so minus k plus 1 by 2. Okay, so now I hope like so yes, now let's look at here. So this is it. n capital N minus k plus 1 by 2. So for all k greater than equals to 1 less than equals to capital N. Okay, and that's the proof for this one, and I hope I have been able to explain it properly. Still, if I haven't been able to explain it, you didn't understand anywhere, please do comment below, and please do share it among the other students as well. Please do like it, and I tried my best here to prove it and to explain it to you all, and yeah, so that's the proof, and so that completes the whole of these 8 problems, and I hope you liked all the solutions. So anything you have to ask, just ask in the comments below. I'll try my best to explain, and so I hope you liked all the solutions. Please do like and share it among the other students, and thanks for watching, and I'll also post the UGA solutions as well. As you all know that I am a one army man, so yeah, I within 2 days or 1 day I'll just post the solutions of the UGA as well. And why I go with the UGB, because many fail to solve UGB problems. Now you can go and check that many haven't been able to solve at even one UGB question as well properly. So whereas I mean, they have a team of 5 or 6. Team of 5 and 6 are required to solve the UGB problem for many institutions. So we are trying our best to solve it on our own. So anyways, again, as I said, I'm doing my best. So please, again, let's help each other to grow as well. So I'm helping you to understand the problems and helping you to grow. So please do help me to grow as well, and please do share the solutions, and please do like them, and thanks for watching, and keep watching and keep learning, and see you in the next one.